Hey guys, how you all doing? I hope you all are doing really good. And I also hope that transmission electron microscope parts and working is crystal clear in your mind. But if it's not, put your doubts in the comment section, see that video again, and still if it's not clear, please see some animated videos, then it'll be crystal clear in your mind. But with that, let's start with the scanning electron microscopy. And I'm not gonna show you how the microscope look like because it's look like pretty same, only the parts and working that is different. So let's get started. See here, scanning electron microscopy parts, right? Now we have some or the other different parts, but we also have some common parts like the electron source. Electron source will be the source which gonna produce the electron beam of light. I'm sorry, electron beam. And thermionic cathode and anode will be helping us to produce that electron beam. Electromagnets will make that beam to the pointed beam. Now, what do I mean by that? Electron source will be producing a blunt beam, like you can see here. Electron source will be producing a beam, a high velocity electron beam. But the thing is, they will be producing a blunt beam, which is not of any use. Electromagnets, which will be acting as condenser lenses, make sure that this blunted beam gets pointed and only then it hits our specimen. Then only we can get the fine details of the specimen. Finally, we have secondary electron detector. Now, if you remember, we classified electron microscope on the basis of how the images are producing. In transmission electron microscope, electrons are passing through the specimen, but in scanning electron microscope, electrons will not pass through the specimen. In fact, when this primary electron beam, this is called your primary electron beam that is produced by the electron source, hit our specimen, secondary electrons getting emitted by the specimen, and these then are detected by our secondary electron detectors. And there are some extra X-ray detectors also, because it might be possible that along with secondary electrons, X-rays are also getting produced, and then these are X-rays, the X-rays getting detected by X-ray detector. Finally, we have scintillator that converts radiations. What radiations? Like the secondary electron radiations, X-ray radiations into light flashes. And then photomultiplier finally convert these light flashes into electrical signal, because we are not looking into the microscope. In fact, we are looking onto the monitor screen. So these data, which is produced by secondary electrons and the X-ray radiations, need to be converted into some electron signals so that our monitor is able to produce all the images. But wait, again, if you're having some doubts like how the secondary electrons are producing, how the X-ray are producing, what I'm here for. Okay, so that will be dealt in some other parts, but now let's look into the working of microscope. See here, we have scanning electron microscoping working. But you know the fact that whenever we are exposing our specimen onto any microscope like scanning, light, we stain the specimen, right? But this time we need to take extra care of our specimen before exposing it to spam, because we know secondary electrons are coming out from the specimen, and we do not want that secondary electrons get collected over the specimen surface. We want them to come out so that they can be detected by our secondary electron detectors, right? So what we are going to do to ensure that no collection of secondary electron takes place on the surface of the specimen surface, we make sure that these specimens are dried, they are dehydrated, and they are also covered with a thin layer of metal so that no collection of electric charge takes place. And other things, and there are better things, how do we use it, how do we stain our specimen for scanning electron microscopy and transmission electron microscopy, will be of course covered in scanning series, but this point you should remember because this is special. Now finally, let's get into the working. Electron gun again will be producing a blunt beam of electron with the help of thermionic cathode and anode, and these electron blunt beam, as I said, is of high velocity. Finally, these blunt beam, or in fact this blunt beam, will pass through our electromagnets, which of course acts as condenser lenses and helps in making that blunt beam into the pointed beam of electrons, so that when that pointed beam hits our specimen, only a fine area is make under the observation. Okay, so that other set of condenser lenses, it might be possible that two sets of electromagnets are used again to make that blunt beam into even pointed beam. Okay, now that beam of electrons is called primary electrons hit our specimen and secondary electrons come out. Now how do secondary electrons are exactly coming out will be dealt in other video. I'm not dealing with how this is happening, how the secondary electrons are coming out when primary electrons are hitting our specimen, because that is not the part of working. That is part of a theory kind of a thing that should not be deal in working, but it is necessary for us to for the clear understanding of scanning electron microscopy that how the secondary electrons are coming out will be dealt in another video. Don't worry. Finally, we have detectors called secondary electron detectors, which are having positive terminal over the point. Like if we are having as secondary electron detector over here, it'll be having positive terminal over here because our electrons are of negative charge, and we need to ensure that all the secondary electrons that are coming out of the specimen get absorbed or get collected. I'm sorry to use the word absorb. It's getting collected by the secondary electron detector. So to ensure that none of the electrons are getting, uncollected by the detector, we are having positive terminal so that they get attracted and then they are collected. Secondary electrons will be getting collected by secondary electron detectors. X-ray radiations will be getting collected by X-ray detectors, and finally we have scintillator. As I said, this scintillator, what will be this scintillator is doing, this scintillator will be converting electron data or electrons into the light flashes. And finally we have photomultiplier, which is making sure that these light flashes converts into electric signal because we are getting our image onto the monitor. Now the last part is that image is produced in screen bit by bit. As I said, now when that pointed, highly pointed beam of electron, primary electron is hitting our specimen, it is hitting only a surface and not is hitting the overall specimen. But what do we need? We need to scan the whole specimen. So what we will be doing, we will be using scanning generators. We will be deflecting this beam, and so that this pointed beam now scans this specimen, this part of the specimen, and finally secondary electron will start coming out from this point. Earlier the secondary electrons were coming out from this point, and bit by bit secondary electrons are getting detected by scanning electron detector, secondary electron detector, and finally the image will be produced. Now, we are not using any light or something like that in a scanning microscope or in any electron microscope. So what images will be appearing brighter and what images will be appearing darker? Brighter images will be the raised areas. As you know, that in scanning electron microscopy, we are using primary electrons that are giving secondary electrons. These secondary electrons are coming out from the surface of the specimen. So what is mainly under observation in scanning electron microscope? It is our surface of the specimen and not the internal structures. Internal structures are also under observation, but only when this beam hits our internal structure's surface and not the specimen surface. Wherever this beam of electron is hitting, only that part is getting into consideration and only that part is detailed in the microscope, in the monitor. So that raised areas over the specimen will be looking brighter. Why? Because this raised area will scatter more electron. But what about the depressions? Those secondary electrons will not be able to escape those depressions, and so only fewer electrons will be coming out of the depressions. So these depressions will appear darker in the image and these raised areas will appear brighter in the image. I hope that's clear. Raised areas will ensure that more number of secondary electrons get scattered, and darker areas, because they are depressions, so secondary electron will not be able to get out of the depressions, will not be able to escape, and finally will be having our these as darker areas in the image. Now, finally, we are having this slide which is helping us to, visualize those parts in working. We have electron source, which is consisting of cathode and anode. Then we having the blunt beam of electron, which is of high velocity, passes through condensers. Now see here, we have two sets of electromagnets to produce a highly pointed beam. This highly pointed beam, when hit our specimen surface, maybe the external surface or the internal surface, produces secondary electrons along with X-ray radiations. These secondary electrons getting detected by secondary electron detector, X-ray radiations getting collected by X-ray detectors, and then finally these secondary electrons are getting through scintillator, then these are going through photomultiplier, and finally in the monitor screen we are getting our image. See, no data signal is connected with this X-ray detectors, because if we want to get the data from X-rays, we'll connect a monitor with this. But what if we do not want that data, but we only want the data coming from the secondary electron? So we'll ensure that only the X-ray detector is there to collect those X-rays and ensure not to damage our other parts. But that will not be of use if we do not want the data from X-rays. This will be clear in the other video again. But then we have backscattered electron. Nobody talks about backscattered electron. What are those? Basically, see, whenever our specimen, whenever our electron, primary electron hitting our specimen, secondary electrons are coming out. But what if these primary electrons get reflected back and no secondary electrons come out? These are then called as backscattered electron, and to ensure that these backscattered electrons do not damage our other parts, we have backscattered electron and no data is produced by them. I'm repeating, whenever the primary electron source or the primary electrons are hitting our specimen, secondary electrons are coming out. But what if these primary electrons only gets reflected by the specimen, reflected back, nothing comes out? So these are called then backscattered, and these are getting collected by backscattered electron. And finally we have the screen which gonna produce every image. Now the last image, last slide of the video. I'm so sorry if this video is getting extended, but this is scanning electron microscope and you have to use your mind and everything to understand these electron microscopes. Okay, finally, now you know we have electron gun, cathode and anode, blunt beam, and finally we have condenser lenses, the specimen. Pointed primary electron beam is hitting our specimen, secondary electrons and X-rays, you know them, detected and scintillator and the photomultiplier. Now that part of working and the parts of scanning electron microscope is completely covered. Nothing is left out. But still, if you're having any kind of silly doubts, any kind of doubts that are, like just not allowing you to understand this microscope, put them into comment section, put them in vague language, no matter, I'll try to understand them and then answer. But ensure that you put them so that this microscope should get clear in your mind. And with that, thank you so much guys for watching this video. I hope parts and everything is getting cleared, but if it's not, I'm telling you again, go watch some animated videos. There the working of the microscope will be crystal clear in your mind. And with that, thank you so much. Like, share, subscribe, and follow for more. This gives us some inspiration, of course. And with that, bye bye and take care.